So in this video, we're going to do two examples of the ratio test. N factorial, let's do 10 to the, well not 10, I guess maybe not 10, let's do e to the n over n factorial. And then with the other one, let's do n to the 100 over e to the n. We want to know if these series converge or not. And so both of these are rather difficult to integrate. I don't quite know what to compare it with. I guess what would I compare it with? I don't know what to compare. I don't have a bn I would compare to each of these with, and so at this point, so I would first run my divergence test, and I say, well, when n goes to infinity, the limit of n to the 100 over en, does it go to 0? Yes, it does. And does en over n factorial as n goes to infinity go to 0? It also does. So my divergence test is inconclusive. So at this point, I'm going to use the ratio test, which says limit as n goes to infinity of an plus 1 over. And so this is equal to limit as n goes to infinity of e to the power of n plus 1 over n plus 1 factorial divided by an, right? So when you divide by an, we can alternatively multiply by 1 over an, which gives me n factorial over en. And so what I personally find very helpful is if I clustered my like terms together. For example, so I'm just going to rearrange some terms. So I get e to the power of n plus 1 over e to the power of n, and then I'm going to get n factorial over n plus 1 factorial. And this is equal to, so e to the power of n plus 1 is equal to e times e to the power of n. And so e times e to the power of n over e to the power of n is e. So I know this is equal to e, and then I know n plus 1 factor is actually 1 over n plus 1. So I did forget my limit here. Limit as n goes to infinity, and this equals to 0. Since this number is less than 1, we can say from our conclusion of the ratio test, our limit is less than 1, so we know that this series will converge. We can do the exact same thing with the next series. So the summation of n to 100 over e to the n over e to the n. If we let our limit of n goes to infinity of an plus 1 over an equals to n plus 1 to the power of 100 e to the n plus 1 plus n to the power of e to the power of n over n to the power of 100. Oops, this is not a plus. Limit as n goes to infinity, and these two fractions are multiplied together. I recluster and I get e to the limit as n goes to infinity of e to the n over e to the n plus 1 times n plus 1 to the 100 over n to the 100. So when n gets very large, this number goes to 1. And en over en plus 1 is equal to 1 over e. So this is equal to 1 over e. E we know is approximately 2.7 something, so we can say that this is less than 1. So we can say that this whole series is converging.